Welcome MEGN 200 to another video demonstration. This is Dr. Wheeler here. I am currently down in CTLM 123, our mechanical engineering teaching lab on campus, and I'm here with a demonstration to show you how to control the speed of a DC brushed motor with your Arduino. So what I'd like to talk about today is, first of all, we'll talk about some common types of motors that you might run into when you're working on projects. We'll talk about pulse width modulation, how we use that to control the speed of a motor, and then we'll finally talk about implementing that speed control with PWM, and I'll have a demonstration for you showing how we'll control the speed of a windshield wiper motor using a transistor and pulse width modulation on the Arduino. All right, first of all, let's lead off talking about some different types of motors. In your kit, you'll actually find several of these types of motors. So the first one is the brush DC motor. This is a common, inexpensive type of motor that uses a permanent magnet inside of it to help generate a magnetic field that keeps the motor spinning. Next up, there's a brushless DC motor, which are found in fancier power tools and then also things like drones and RC aircraft. So generally, a brushless DC motor for the same power will be lighter weight, which is why they're popular for those drone and power tool type applications. Next up is a servo. So a servo is a motor that's not really intended for continuous rotation most of the time. What it does is it goes to a very specific position. So if you need precise position control, something like a robotic arm, a servo tends to be a really common way to implement that type of control. And then finally, there's also stepper motors. So a stepper motor is a motor that moves in distinct steps, right? So it slowly will click between these different steps, and we can use that to get very precise control of position when we need a lot of different rotations. So if we need multiple rotations, we tend to use a stepper motor. You'll see these a lot in places like 3D printers, regular 2D ink printers, inside of CD drives to move the laser around for reading the CD. Anytime you have an application like that, you tend to see a stepper motor. Now, the speed control we're talking about today is specific to the brush DC motor. Right, so if you want to control one of these other types of motors, like the brushless or the servo or the stepper motor, those require a different circuit and a slightly different code to take control of those. So what we'll be focusing on here is specific to that brush DC motor today. So how exactly does a brush DC motor work? Inside of the motor, there's loops of wire, which we typically call the motor windings. Okay, those windings are inside of a permanent magnetic field. So there's a permanent magnet inside of the motor generating a magnetic field. And when we run a current through the motor windings, the interaction between the electric field of the motor winding and the permanent magnetic field produces a force. And we generally set that force up in such a way that it's producing a torque around the axis of the motor that can spin. So that's how we get the motor to actually move. So the key thing that we need to know if we want to control the speed of the motor is that the more voltage we supply to the motor windings, the stronger the torque that the motor is going to produce. So if we keep everything constant in the rotor of the motor, like a constant moment of inertia, the higher the voltage we apply to those motor windings, the bigger the torque, the more angular acceleration we'll get, and the faster this motor is going to rotate. So that's the key point of what we're trying to do here is we're trying to control the voltage going to the motor, because the higher the voltage we send to the motor, the faster it's going to rotate. All right, so now the question is, how do we send this varying voltage to a motor with the Arduino? Okay, so the problem with the Arduino is it only generates an on-off voltage signal. The output is either 5 volts or it is 0 volts. All right, so we need to simulate sending this changing voltage to the motor somehow to take control of the motor and change its speed. And the solution that we use to do that is called pulse width modulation. So in pulse width modulation, we're rapidly switching the voltage on and off. So the idea here is if we change the voltage quickly enough, if we flip it on and off rapidly, the motor is not going to notice that we're not supplying it with a continuously varying voltage signal. It's just going to keep spinning, and by rapidly changing the voltage, flipping it on and off, and then changing the percent of the time when the voltage is high, we can simulate having an analog voltage control. So the key thing here, the percentage of the time when the voltage is high is called the duty cycle. So let's take a look at an example of what this is going to look like. All right, so here we have a graph of a pulse width modulation signal with a 0% duty cycle. So that just means that the voltage is off all the time. So it's always 0 volts. You can see our average voltage there is given in the red dashed line, and it is also 0 volts. So nothing very exciting is happening there. Now, this is a 100% duty cycle where we have our voltages just on 100% of the time. So the voltage is always 5 volts. And again, our average voltage is 5 volts. Let's look at something in between 0 and 100%. So if we have a 25% duty cycle, we can see here is the power is on for 5 volts for 25% of the time, and then it's off the rest of the time. And our average voltage actually works out to be a little bit more than 1 volt in this case. We could do a 50% duty cycle where our average voltage is going to end up being 2.5 volts, and our voltage is on half the time, off half the time. And then we can also look at a 75% duty cycle, so you can see the time when the voltage is high is increased a little bit more, and our average voltage ends up being over 3 volts in this case. So we can vary our voltage that we're supplying to the motor by changing the duty cycle of the pulse width modulation signal. So how do we actually use this PWM signal to take control of our motor and control its speed? So the basic idea is kind of illustrated by this circuit here, where we have our motor, right? We have a DC power supply, and then we have a switch. All right, so the idea here is we want to rapidly flip that switch on and off, varying the percent of the time when the switch is closed, or the power's on to the motor, and that will simulate being able to change the voltage supplied to the motor. So what we need to do is we need to use the Arduino to rapidly open and close that switch. And to do that, we're going to use a component called the transistor in your kit. So a transistor is a semiconductor device. There's some pretty good explanation on how they actually work in this week's assignment. So that's part of your assignment, is to do that reading and figure out how the transistor works. But the basic idea of it, it's an electronically controlled switch. So when we send a signal to the transistor, it becomes conducting and allows current to flow through our circuit and supplies power to the motor. Okay, so the transistor is what's connected to our pulse width modulation pin and what's controlling the current going through the motor. All right, so from here, we'll go ahead and we're going to jump over to the demonstration bench, and we'll show you exactly how you can implement this PWM control with the windshield wiper motor. So that's a significantly larger motor than what's in your kit, but the idea behind this circuit is the same as what you'll be doing with the small motor in your kit. Okay, welcome over to the demonstration bench. So what I've set up here is a motor control example where we'll be using that transistor to control the speed of our windshield wiper motor. All right, so this right here is the windshield wiper motor. It has a gearbox attached to it so that this disc up here is going to end up spinning. So I added this disc, so it should be really easy for you to see on the video of how quickly it's spinning. Connected to the motor leads down here is a module with our transistor on it. Okay, so the transistor is, again, it's our switch that we're going to be rapidly flipping on and off to control the speed of this motor. So coming into the transistor through these leads here, we have our 12 volt power supply. So this plugs into the wall and it produces 12 volt direct current that will be switching on and off with the transistor. Also attached to the transistor are these two leads right here, which lead back to the Arduino. So one of those is a ground connection, and the other one is connected to one of our PWM pins on the Arduino. Now, also connected to the Arduino over here is our oscilloscope. Okay, so the oscilloscope is an instrument which will measure our voltage as a function of time, and it can respond very quickly, so we'll be able to see that pulse width modulation signal coming to the transistor. I can actually bring this oscilloscope up on the screen. There it is. All right, so down here on the x-axis, that is our time. That's demarcated in milliseconds. And then up on the y-axis up here, that is voltage. So it's going from about 10 volts to negative 10 volts right now. So we'll be able to see that 5-volt signal coming from the Arduino. Now you'll notice that the Arduino is currently not plugged in, so nothing's happening. I have a sketch loaded on the Arduino that's going to ramp up the duty cycle of the pulse width modulation signal from 0 up to 100%, and then it ramps back down. So what we should see is we'll see that signal changing on the oscilloscope, and we should see the motor start off slow, ramp up to full speed, and then ramp back down to stopped. So we'll take a look and watch what happens when I plug the Arduino in here. Now you are going to hear a pretty distinctive whining noise from the pulse width modulation since we're creating this square wave signal that's rapidly changing in time. It's actually within the range of human hearing, so there's a pretty distinctive whining sound that you'll hear from that. So be ready for that when it comes on. All right. So we can see as the pulse width modulation increases its duty cycle, the motor spins faster, and then it starts to spin slower until we come back to stopped. And we keep ramping back and forth there. So you should notice that when the duty cycle is high, what we see is we see the motor spinning quickly, and then it ramps back down. When the duty cycle is low, the motor is spinning slowly until it's stopped when the duty cycle is really, really low. Now you'll also notice on our transistor module, there's a little LED that lights up with the pulse width modulation signal. So this is exactly the same as what we did in class when we were fading an LED with pulse width modulation. We're doing the same thing on that board. So you can see the LED gets brighter when the PWM duty cycle increases, and then it fades back down as the duty cycle decreases. All right, so this is the fundamentals of how we can control our speed of a DC brushed motor with pulse width modulation. You'll get a chance to try this out in class this week. Later on, we're actually going to show you a more advanced circuit that you can use to do forward and reverse speed control of your motor. So be on the lookout for that. That's coming up in class. But until then, we look forward to seeing you in class, and we're happy to help you out building your circuit and taking control of your motor.